It's widely known that a colossal space rock slammed into Earth millions of years ago, erasing the dinosaurs from existence. Thanks to cutting-edge technology, scientists have now pieced together a detailed timeline of this catastrophic event, revealing what truly unfolded. Not only that, they've traced the origins of this massive asteroid. Could Earth be in the crosshairs of another enormous space rock? And would humanity survive such an impact? NASA astronomers have uncovered findings that are both astonishing and chilling. Brace yourself for a journey back to the cataclysm that nearly obliterated life on our planet. Around 65 million years ago, a gigantic asteroid struck shallow waters in what is now the Gulf of Mexico, triggering a cascade of disasters. The initial impact was devastating enough, but it unleashed a chain of calamities. Debris rained from the skies, wildfires roared across landscapes, and towering tsunamis submerged far-off coastlines. Researchers, in a study published in the Proceedings of the National Academy of Sciences, detailed the chaos of the first day of the Cenozoic era. Their timeline was crafted using advanced techniques like high-resolution photography, microscopy, computed tomography, and magnetic analysis of hundreds of feet of sedimentary rock extracted from the Chicxulub crater, one of Earth's largest impact scars. Here's how it all began. Picture yourself in North America 65 million years ago, a time when dinosaurs dominated the land. Gazing at the night sky, you might notice a bright speck, resembling a star, glowing faintly in the distance. But if you kept watching for an hour or two, this star would grow brighter without shifting position. What you're seeing isn't a star at all. It's a massive asteroid, 11 to 80 kilometers wide, 7 to 50 miles, hurtling toward Earth at a staggering 72,420 kilometers per hour, 45,000 miles per hour. Hours later, this behemoth tears through the atmosphere, zeroing in on the region we now call the Yucatan Peninsula. At such an immense speed, Earth's atmosphere behaves like a liquid. Smaller meteors, like pebbles tossed into a lake, slow down quickly at high altitudes, burning up or fragmenting due to atmospheric friction. But this mountain-sized Chicxulub asteroid crashes through the atmosphere like a boulder smashing into a shallow puddle. In just 3 seconds, it slices through 60 miles of atmosphere, barely losing speed. As it streaks over Central America, it unleashes a deafening sonic boom, powerful enough to rupture eardrums across continents. Dinosaurs nearby would have been gripped by panic, scattering in all directions, unaware of the impending doom. Any creature close enough to witness the asteroid's descent would be vaporized in moments. In fact, aside from sea turtles and crocodiles, no land animal heavier than 25 kilograms survived the aftermath. The asteroid's descent is so rapid that the air can't escape its path. Compressed under immense pressure, the air heats to thousands of degrees in an instant, vaporizing much of the shallow sea covering the Yucatan before the rock even strikes. Milliseconds later, the asteroid slams into the bedrock, setting off a catastrophic chain reaction. The impact exerts such force that soil and rock behave like liquids, flowing outward. Imagine a cannonball dive into a pool. The initial splash radiates in all directions, followed by a secondary vertical surge as the crater rebounds. The first wave of displaced Earth forms a wall over 32 kilometers high, 20 miles. The impact carves a hole so deep it nearly pierces Earth's mantle. When the crater rebounds, the ground surges upward at over 1,600 kilometers per hour, 1,000 miles per hour, forming a peak taller than Mount Everest. Within minutes, this towering debris collapses in a series of explosive secondary blasts, leaving behind a smaller central mound, known as the crater's peak ring. At the moment of impact, the asteroid, a 7.5 billion-ton rock traveling at 16 kilometers per second, 10 miles per second, converts its kinetic energy into blistering heat. The Chicxulub impact releases roughly 1 septillion, 300 sextillion kilojoules of energy, 1 septillion, 300 sextillion, equivalent to a billion Hiroshima bombs. This energy heats the surrounding soil, rock, and air to temperatures hotter than the sun's surface, stripping electrons from atoms and creating an expanding plasma fireball laced with vaporized rock, ejected at hypersonic speeds. The combination of superheated air, vaporized Earth, and the impact shockwave generates a massive blast wave, racing outward at over 1,600 kilometers per hour, 1,000 miles per hour. If this asteroid struck today, the blast would incinerate everything in Texas, deafen people in New York, and shatter windows as far away as Buenos Aires. The impact reverberates through Earth's crust, sending seismic waves radiating at 4 kilometers per second, 2.5 miles per second, triggering earthquakes across the globe. If you were on the opposite side of the planet, you'd feel the ground tremble 30 minutes later. The impact also spawns tsunamis as tall as skyscrapers. Within an hour, waves up to 600 feet, possibly 1,000 feet, crash into the Gulf Coast, flooding tens of miles inland. These waves reverse river flows, surging upstream like 30-foot tidal bores. 6 hours later, 600-foot walls of water hammer Europe, Africa, and the Mediterranean. Within 15 hours, every coastline on Earth is battered, with oceans sweeping away everything in their path before retreating. As if this weren't catastrophic enough, more devastation looms. The impact launches 25 trillion tons of debris on ballistic paths, some escaping Earth's gravity to orbit the Sun or even reach the Moon. Most of the debris hurled into the sky by the Chicxulub impact returned to Earth within an hour. These molten fragments, known as tektites, range from marble size to as large as buses, raining down at speeds of 160 to 320 kilometers per hour, 100 to 200 miles per hour, in a deadly barrage. No matter where the surviving dinosaurs were, they faced a fiery onslaught from this hailstorm of glowing glass. Yet, these tektites didn't need to strike directly to be lethal. As they plummeted through the atmosphere, their friction generated intense thermal radiation, igniting wildfires across the globe. Some estimates suggest the combined heat from these falling embers turned Earth into a giant oven set to broil. Most of the planet's forests were consumed in flames, which may explain why only ground-nesting bird species survived the catastrophe. The few larger land animals that escaped extinction had ways to shield themselves from the scorching heat. Small mammals, snakes, and lizards could burrow underground, while crocodiles and turtles sought refuge in water. Even dinosaurs on the far side of the planet needed to find cover from the initial heat blast to have any chance of survival. Adding to the dinosaurs' misfortune, the Chicxulub asteroid struck a region rich in oil and sulfur. The impact vaporized and ejected 100 billion tons of sulfur and 30,000 quadrillion gallons of water into the atmosphere. This material condensed into massive storm clouds, unleashing torrents of acid rain that poison the oceans. In higher latitudes, continent-wide blizzards dumped tens of feet of snow daily. The deluge was short-lived, however, as the impact also vaporized 150 football stadiums' worth of oil from the Yucatan bedrock. This oil formed a thick, sooty layer in the stratosphere, coating the Earth like black paint. Unlike the sulfur and wildfire smoke, this carbon layer lingered high above the cloud level, preventing it from being washed away by rain. This created a new crisis. The soot blocked 90% of sunlight from reaching Earth's surface for 2 to 3 years, plunging the planet into a deep freeze. Global temperatures plummeted by nearly 50 degrees. Only tropical islands like Madagascar, India, and Indonesia escaped the worst of this chilling period. With evaporation nearly halting, rainfall dropped by 80%, transforming most of Earth's landscapes into deserts outside these tropical havens. Where did this catastrophic asteroid come from? And could another be on its way? Using supercomputer simulations and data from known asteroids, researchers Avi Loeb and Amir Siraj proposed that the Chicxulub impactor likely originated from the Oort cloud, a distant sphere of debris at the solar system's edge. It may have been a massive comet, nudged off course by Jupiter's gravitational pull and fragmented near the Sun into smaller pieces. These fragments could cross Earth's orbit, potentially striking the planet every 250 to 730 million years. According to their findings, another massive impact isn't a question of if, but when. On December 11, 2021, NASA reported that a 330-meter asteroid named 4660 Nereus passed Earth at a distance of 3.8 million kilometers, 2.4 million miles, traveling at 6.5 kilometers per second, 14,719 miles per hour. While this may seem far, a slight orbital shift could put it on a collision course with Earth in the future. Astronomers are monitoring this potentially hazardous rock, predicting it will come within 1.1 million kilometers, 745,000 miles, of Earth on February 14, 2060. Plan your Valentine's Day celebrations early, just in case. For context, the asteroid responsible for the 2013 Chelyabinsk explosion in Russia was only 20 meters wide. Currently, humanity lacks a proven defense against a massive asteroid. However, NASA's DART Double Asteroid Redirection Test mission is testing a potential solution. DART aims to autonomously navigate a spacecraft to collide with Dimorphos, a small asteroid moon orbiting the larger asteroid Didymos, to alter its trajectory. Scheduled to reach the Didymos system in late September 2022, when it's 11 million kilometers, 7 million miles from Earth. The collision is expected to change the moonlet's speed by a fraction of 1%. However, deflecting a 10-kilometer wide asteroid traveling at over 72,000 kilometers per second would require far more than a single spacecraft impact, perhaps even nuclear weapons, as depicted in films like Armageddon. Could you devise a way to stop a planet-killing asteroid? Your idea might just make you famous. Share your thoughts and stay tuned for more thrilling updates about our universe. Thanks for watching, dear friends.